Hello friends, welcome to my channel. This is chapter 3 of physics of concise book Force and Pressure. So basically we are going to study in this chapter about force and about pressure. What is force and pressure? So let us start this chapter, but before starting this chapter I want to say that you please recommend me in the comment section that on which topic should I make video, means about which subject or about which particular topic, so that I could be clear and I could get a clarity that my videos are helpful to you. And please subscribe to my channel to get regular updates and to make me clear that my videos are helpful to all of you. Now, first is what is force. So basically a force is a push or pull which results in the movement or change in shape and size of a body. Means basically that whenever we give any push or any pull to a body, or we changes its shape or size, we apply some energy, and that energy could also be said as force. So whenever we give force, it is obvious that anything will happen. Either there will be movement or there will be change in the shape or size of the body, and then only in the language of physics we say that work is done. So we could say that always when force is given, work is done. But it is not necessary that um, whenever we give force, work is done. Whenever work is done, force is given. But it is not true that whenever force is given, work is done. Because if we push or pull a wall, it is not like the work will not happen, because the movement of wall will not happen even though we are giving force. So their work is not happening. Okay. Next is a force when applied as push or pull on stationary body which is free to move can produce motion in it, and if applied on a moving body, if it can change the speed of motion on a body. And if a force is applied on a stationary body, either it will produce motion or it will change its shape or size. But if the body is in motion and if we give it further force, there will be an increase in the speed of the body, or it can change both the speed and direction of motion. Similarly, the shape and size of a non-rigid body can also be changed by applying a little amount of force. However, if a body does not move, on application of force in its size and shape does not change, then in the language of physics, the force which we are applying is not fruitful, and in that case work is also not done. Then a force roller initially at rest when pulled begin to move. A fielder when catches a ball stops the moving ball, and further examples are given. So I am not going into each and every example because my basic concept will be to clear the concept of force, pressure, and whatever topics are given in this chapter. So these things as you could do, so I am not going into each and every examples of this chapter. Now some points are there in this chapter to note. A force does not change the mass of the body on which it is applied. Obviously the mass can neither be created nor be destroyed, so even if we are giving force, the mass of the body will not be affected. We cannot see a force, however we can see or feel the effect of force. So we can't see a force, but we can feel the effect of force. A force is expressed by stating both its magnitude and direction. So we can express a force by both how much force we have given, that is the magnitude, and what is the direction of the movement of the body in which we have given the force. A force is represented by an arrow. This arrow, the length of arrow is a measure of its magnitude and the arrow heads shows the direction. So the arrow's head shows the direction in which we have given the force, and the length of the arrow shows the magnitude. Then what is the unit of force? So basically, as Sir Isaac Newton has discovered force, so the SI unit of force is Newton. So we can see that when a 1 Newton force is applied, if we are giving a certain amount of force on 1 kg object, and by giving that force, there has a increase in the motion. There has been increase in 1 meter per second increase in the motion of the body. For example, if a 1 kg object was moving at 20 km per second, but after giving force, it started moving 21 meter per second. Like first it was moving 20 meter per second, then 21 meter per second. So 1 meter per second it is increased in its speed. That means the force which I have given is 1 Newton. We have read that our earth also exerts a certain amount of force which is equal to the weight of our body. So the force of gravity that acts on a body, that is also kind of force. So the SI unit of that force is also Newton. At a place, if we are standing at a place on a plain region, then the force of gravity which we will feel due to our mass, that will be, in other words, 1 Newton, the force of gravity at a place on 0.1 kg. Means if our weight is 1 kg and we are standing on the surface of the earth, we could feel a 10 Newton weight on our body if our weight is 1 kg. If a certain body has 0.1 kg weight, then 1 Newton force will be applied. Or we can say if a 100 gram mass is kept. Now this can change. If we are going towards high region like mountainous region, the gravitational force will decrease. So a 1 kgf is equal to 10 Newton nearly. So these mathematical calculations we will learn in our numerical portion of this chapter when we will do. So if you will see me to do numericals also, then I will make a separate video on numericals for this chapter. Then is the turning effect of a force. Like what is a turning effect? So like if a body is pivoted or is fixed at a point and it could not move whole, and if we are giving force to that object, then we will see that the body turns on its own position and at a particular axis. That axis is known as axis of rotation. Suppose we are giving force to a door. Now door is pivoted at one side and at the another side we are giving it force. So what will happen, that it will move, and the movement, the axis on which it will move is known as axis of rotation, and the point at which it is pivoted is known as pivot, and we are giving force. So in this image we could see the labeling. Then there could be many examples. If a nail, we are putting a nail, then also certain these kind of things, if we are rotating a nail which is fixed at a point, and a wheel also which is fixed at the axle, shows the turning effect of a force. Then thus a force or we can say push or pull has a turning effect on a body. Now these turning effect, so there can be two factors that affect the turning effect of a body. Obviously the magnitude, and second is the perpendicular distance of the force from the pivoted point. For example, in this image in this image what we could see is a girl is pushing the wall from the end. This particular point is pivoted, and we could see that this girl is giving force from the another end. What it is showing, the perpendicular distance of the force from the pivoted point. This is the pivoted point and the girl is giving force from this end. So it would be easier for the girl to close the door by a little amount of force. But on the other hand, if the girl is giving force from this point or this point, it would be difficult for the girl to close the door with a little amount of force. So that is because of the perpendicular distance of the force from the pivoted point. Then the magnitude of the force applied. So obviously the magnitude will differ a lot. If we are giving very less force on the door will not completely close at a time, or it will close slowly. But if we are giving a high force, there will be a difference obviously. Now some examples which we could see in our daily life, as like the first example is of door only. When we try to shut a door, we apply a force on the hinges, and the hinges is present on the another side of the pivoted point. Why? This is because that in that case we will require much less force to give on the door so that the door could be closed. So that is what written in this particular point. Point number 2 is the upper circular stone A of the handle floor grinder is pivoted with a handle H near its rim at the maximum distance from center so that it can easily be rotated about the iron pivot P at the center by applying a small force at the handle. So this is the stone particular, and we have to move this stone to grind that particular thing which is given in the this floor grinder. So if we are giving wheat or anything else, then we have to move it. So what we can do is, like, we have to see these two things. First is the magnitude. So how what is the force we are giving? If we are giving a high force, obviously the floor grinder will move fastly, and if we are giving less force, it will move slowly, and the work will be also done slowly. And the second thing is perpendicular distance. So if we are keeping this stick near this pivot, like somewhere here or here, it would be difficult for us to move that circular stone. Whereas if we are keeping it in the end here or here, it is easier for us to move that, because obviously if we are keeping it in the pivoted point, it will not be easier, it will be harder for us. That is. Then same example of when a potter moves the particular stick particular rim with the help of a stick to make the utensils and all. Then when a carpenter uses a drill machine, he also holds the particular drill machine at the end, so that he have to give much less force at the end, and the drill can be turned easily. Then when we are moving the steering or wheel of a car or a truck, then the driver applies much little force at the rim then near the pivoted point. So this is the pivoted point. So if somebody is holding here and moving this one, it is much harder, but if somebody is moving the rim, it is easier. And then in a bicycle also, this axle is a fixed point. So if somebody is moving this pedal from here, it is harder, but we have to give force here at the foot pedal, so it is easier for us to move that. Then a spanner, in here also we give force here, not here, and if we give force here, it is much harder for us to move this, so that to open the nut. So we could have further conclusions that for to move any body with less force and much easily, the perpendicular distance from the pivoted point should be much high, and the magnitude should be much large. Then movement of force. Movement of force is basically the amount of movement the body has done when we have applied force. Suppose if we have given a certain amount of force from a certain amount of distance at a door, so what is the movement the door will show? That is the movement of force. The formula for movement of force is force into perpendicular distance, that is F into OP. OP is the perpendicular distance from the pivoted point O. Then unit of force. So we could find the unit of force from the formula itself. We know that the formula for force is Newton and the formula for distance is meter. So when we multiply Newton into meter, we will get Newton meter, and Newton meter is the SI unit of moment of force. And on the other hand, if we want to find the CGS unit of moment of force, we will write that like the CGS unit of force is dyne and the CGS unit of distance is centimeter. So the SI unit is dyne centimeter. And then further examples are given. This particular thing you could see, we will discuss these things in the numerical video. Then thrust. What is thrust? So thrust is little bit related to force and it is also related to pressure. So basically, what is thrust? Thrust is force only, but it is a perpendicular force given to an object. A force can be applied on a surface in any direction, but if a force is applied on the surface on the direction in a perpendicular direction, means in the direction of normal to the surface, the force is called thrust. Thus, the force acting normally on the surface is called thrust. A body, when placed on a surface, exerts a thrust on the surface equal to its own weight. So, whatever the thrust is there, whatever force we are giving to the object, that is equal to the own weight of the body. So if we have kept a particular object thrust which it will apply on the ground, which it is equal to the weight of the body. What is the unit of thrust? So the unit of thrust is same as weight or force. Thus the unit of thrust is kilogram force or gram force or Newton. So basically thrust is force. So the SI unit of force which it is equal to the SI unit of thrust, which is Newton. It could also be kgf or gf, and that is kilogram force or gram force. Then what are the effects of thrust? So the effects of thrust we are going to discuss in our next video. Till then, bye bye. Like, share and subscribe to my channel for further videos, and please comment me down on what topic the next video should be, and please subscribe to let me know that my videos are helpful to you. Thank you.